Example problem 6 reads, 5 grams of neon is at 256 millimeters of mercury and at a temperature of 35 degrees Celsius. What is the volume? So when y'all see grams or moles or the letter N, which is what we use to represent moles, you should immediately think the equation PV equals nRT. Because the combined gas law equation, there's no variable in there for grams or moles. So when you see grams or moles, you should immediately think ideal gas law. So it's pretty straightforward asking us what is the volume. So that means we are going to have a P, we're going to have an N, we're going to have an R, and we're going to have a T. And there's not two sets of things like there were with the combined gas law equation. There's just one set of everything. So P is going to be pressure in units of ATM. And the reason why it has to be in units of ATM is because of the universal gas constant, which is R. So that's 0.082. Well, you can say 0.0820, or I usually just write it as 0.0821. And then you have liters, ATM, moles, and Kelvin. So this right here is why everything has to be in liters, ATM, moles, and Kelvin. So pressure in ATM, N is your number of moles, R is your ideal gas constant, which again is every single one of these. So liters times ATM divided by moles and Kelvin. And that'll help you remember, if you can remember this, all of the other units. And then, of course, temperature has to be in units of Kelvin. So let's start where the problem tells us. So we have 5 grams of neon, and we have to make sure that we make grams of neon go to moles of neon, and that is a one-step conversion because, remember, moles is treated like a base unit, and grams would be treated like something with a prefix would in the metric system. So if you're going from a base unit to something with a prefix, that would be a one-step conversion. So this is a one-step conversion. So 5 grams of neon gas, draw your multiplication symbol, draw your division bar. Grams of neon goes to the bottom, moles of neon come to the top. And 1 mole, according to the periodic table of elements, neon is in group 8 because it's a noble gas. It's number 10 and its mass is 20.18. So 20.18 grams per 1 mole. Grams of neon cancels and you're left in moles of neon. So 5 divided by 20.18 is 0.247, so 0.25 moles of neon. So at this point, if you're really confused about what I just did, I would encourage you to stop listening to this, go back to the gas law for chemistry or chemistry for gas laws lecture. There are, I think, 27 example problems that handle these kind of conversions. So I would encourage you to stop this video now and go back and practice some of those problems because this type of conversion is very important for gas laws going forward. If you're comfortable with this, then we'll move on to the next part of the problem. So our N is now 0.25 moles of neon. So that's in its correct units. 256 millimeters of mercury. We need to convert to ATM. So 256 millimeters of mercury. We know this is a one-step conversion from our previous problems. So in 1 ATM, there is 760 millimeters of mercury. So in your calculators, 256 divided by 760 is going to give us an ATM of 0.336 or 0.34 ATM. So pressure is now 0.34 ATM. A temperature of 35 degrees Celsius, so that has to be changed into Fahrenheit. So 35 degrees Celsius plus 273.15, again, another conversion that we previously learned. So 35 plus 273.15 is going to be 308.15 Kelvin. So 308.15 Kelvin. And R is going to be the same in every single equation. R is the ideal gas constant. It's the same every time. That's why it's called a constant. And that is 0.0821 liters ATM divided by moles Kelvin. So now we're ready to put all of this into the ideal gas law equation. And we're going to do it at the top of the screen since there doesn't look like there's much room left at the bottom. So pressure, 0.34 ATM. Volume is what we're looking for, so we'll put an X here, equals a number of moles, which is 0.25 moles. R, which is always the same no matter what, 0.0821 liters ATM, mole, and Kelvin. T is 308.15 Kelvin. All right, so we're ready to isolate X. So to isolate X, we just divide by 0.34 ATM, and that cancels. So divide by 0.34 ATM. And so we can see here where Kelvins cancel, where ATM cancels, where moles cancel, and there's nothing for liter to cancel. There's no other pair for it. So that's the appropriate unit for volume in this equation. So in our calculators, 0.25 times 0.0821 times 308.15 divided by 0.34 gives us a final volume of 18.60 liters. Let me know if you have any questions about example problem 6.